Welcome back to my YouTube channel Grandpa Mathematics. Today let us do some more problems on miscellaneous exercise of chapter 7, that is integration. So we have to evaluate this integral dx by square root of sine cube x into sine of x plus alpha. Let's take dx by square root of sine power 4x into sine of x plus alpha by sine x. So multiplied numerator and the denominator by sine x. Now you can take sine power 4x outside. That will become dx by sine square x. This will become square root of sine of x plus alpha by sine x. Why we are taking like this? If we take sine of x plus alpha by sine x as y, and if we differentiate, the denominator sine square x will come. So here denominator sine square x is there. So we have to see whether this will become part of dy. So let sine of x plus alpha by sine x, this is equal to y. If we differentiate, what will come? This is in the form of u by v. So v square dy by dx is equal to u by v form. V square sine square x v sine x into differentiation of u, that is sine of x plus alpha. If we differentiate this, we'll get cos of x plus alpha minus sine of x plus alpha and if we differentiate the denominator, cos x. The numerator is in the form sin a cos b minus cos a sin b, sin of a minus b form. So sin of a minus b, x plus alpha, this form, divided by sin square x. If we simplify, what will come? X minus x minus alpha. So sin of minus alpha by sin square x. Therefore 1 becomes, now dx by sin square x. Dx by sin square x is nothing but minus dy by sin alpha. Minus is there, and square root of this we are taken as y. So this nothing but minus 1 over sin alpha integral y power minus half dy. This is in the form of integral x power n dx. If we integrate x power n with respect to x, what will come? X power n plus 1 by n plus 1. So it will be y power minus half plus 1, that is y power half by half plus constant. So this becomes now minus 2 by sin alpha square root of y. Y is nothing but sine of x plus alpha by sine x plus constant. So this is the answer. We have to evaluate this integral. You see here square root of 1 minus root x by 1 plus root x is there. So 1 minus something, 1 plus something means what value we have to substitute for x? So we know that 1 plus cos 2 theta is equal to 2 cos square theta. 1 minus cos 2 theta is equal to 2 sin square theta. 1 minus sin 2 theta is equal to sin theta minus cos theta whole square. 1 plus sin 2 theta is equal to sin theta plus cos theta whole square. X is equal to what? What value you have to substitute for x? The square root should go. So you have to substitute 1 plus 1 minus is there, 1 plus 1 minus is there. So we can get square. So that means we have to write x as cos square 2 theta. X is cos square 2 theta. Then what is dx will come? So this is in the form of cos 2 theta whole square. It is x power n form. So n into x power n minus 1. So 2 into cos 2 theta in power 2 minus 1. That is 1. Again this is not theta. We have to differentiate this. Minus sin 2 theta cos, again it's not theta, 2 theta is there. We have to differentiate 2 theta with respect to theta, 2 will come into d theta. Therefore 1 becomes integral square root of 1 minus x is cos square theta, square root of x is cos 2 theta. So 1 minus cos 2 theta by 1 plus cos 2 theta. Then dx is minus 4 times sin 2 theta into cos 2 theta d theta. So 1 minus cos 2 theta is 2 sin square theta. One plus cos 2 theta is 2 cos square theta is sin theta by cos theta will get. I want to cancel. Denominator cos theta is there. Whether any cos theta is here, we have to see. So if we expand sin 2 theta, we'll get 2 sin theta cos theta into cos 2 theta d theta. So this cos theta is, gets cancelled. Take minus 4 outside. Integral 2 sin square theta into cos 2 theta d theta. Now how we can proceed? Cos 2 theta we can write in terms of 1 minus 2 sin square theta. Then sin square theta will be the sin power 4 theta. Thus it's not easy to integrate. Even if you write 2 cos square theta minus 1, again it is not easy. So we can convert this using, what is the formula we know? 2 sin square theta is, we already seen 2 sin square theta is nothing but 1 minus cos 2 theta into cos 2 theta d theta. Great. But the cos square 2 theta, what we have to do now? Again, we can write this as minus 4 times integral cos 2 theta d theta, minus into minus plus 2 times integral 2 cos square 2 theta d theta. Once you write a 2 cos square theta form, 2 cos square theta is 1 plus cos 2 theta. 2 cos square 2 theta is 1 plus cos 4 theta. So this is nothing but minus 4 times integral cos 2 theta plus cos 4 theta d theta. So minus 4, if we integrate cos 2 theta with respect to theta, we will get sin 2 theta by 2 plus, if we integrate 1 with respect to theta, we will get 2 theta plus 2 times, if we integrate cos 4 theta, we will get sin 4 theta by 4 plus constant. Now we have to replace theta in terms of x. Because this is 3. Cos square 2 theta is x. From there we have to find sin 2 theta, theta and cos 2 theta. So we write cos square 2 theta is equal to x. So this gives cos 2 theta is square root of x. So this value we have found. Theta value we have to find. So this gives 2 theta is equal to cos inverse root x. Now we have to find the value of sin 2 theta. So sin square 2 theta is nothing but 1 minus cos square 2 theta. Cos square theta is, cos square 2 theta is x. Cos square 2 theta is 1 minus x. So this gives the value of sin 2 theta is equal to square root of 1 minus x. Therefore 3 becomes minus 2 times sin 2 theta is square root of 1 minus x plus 2 theta is cos inverse x root x, cos inverse root x plus sin 2 theta into cos 2 theta. Sin 2 theta square root of 1 minus x, cos 2 theta is square root of x plus constant. X minus x square plus constant. So this is the answer. So in this problem, we have to evaluate integral sin x cos x by cos power 4x plus sin power 4x with respect to x. So what you should take as y so that the numerator becomes part of dy. We take sin square x is y, we take, let y is equal to sin square x. If we differentiate, we have to change the limit also. When x varies from 0 to pi by 4, when x is 0, sin 0 is 0, so y also becomes 0, and when x is pi by 4, y is equal to sin 45 degrees 1 by root 2. 1 by root 2 whole square is 1 by 2. So y is equal to 1 by 2. Therefore 1 becomes integral x varies from 0 to pi by 4. Then y varies from 0 to half. Sin x cos x into dx is dy by 2. Sin square x we have taken as y. So we have to express this in terms of sin square x. How we can express? Cos square 1 minus sin square x is, this is cos square x whole square. This becomes cos power 4x. Then this is sin square x whole square. Now this is equal to integral 0 to half dy by 2 times 1 minus sin square x is what? Y. 1 minus y whole square plus y square this we have to simplify further. We can take 2 outside the integral. 1 by 2 times integral 0 to half dy by, if we expand this, we'll get 1 plus y square minus 2y. Y square plus y square is 2y square minus 2y plus 1. So I is equal to half times 0 integral 0 to half dy by 2y square is there. Take 2 outside. Then it will become y square minus y plus 1 by 2. So this becomes 1 by 4 times 0 to half dy by, this is a square minus 2ab term. A is y, so you have to do, this is 2ab. 2ab is equal to minus y. A is y, so b is equal to 2ab by 2a. 2ab is minus y, 2a is y, so minus half. So b is minus half. So a minus b whole square, and this y square minus 2y into half is minus y, plus 1 by 4 is there, so plus 1 by 4. So that means we can write this 1 by 2 whole square by 4 times. So this is in the form of integral dx by x square plus a square form. Then what is the formula? 1 by a into tan inverse x by a, that is y minus half by half limit 0 to half. This becomes 1 by 2 times. Now we'll simplify this further. Tan inverse of 2y minus 1 by 2, 1 by 2. So this 0 to half now. Now for y, we will substitute half. So 2 into 1 minus 1, 0. Tan inverse 0 is 0 only. Minus, if you put y as 0, then it will become tan inverse minus 1. So what is tan inverse minus 1? Is nothing but minus tan inverse 1. Minus into minus, that will become plus. So half times tan inverse 1. So half into pi by 4 is equal to pi by 8. So this is the answer. So in this integral, cos square x is there in the numerator and cos square x plus 4 sin square x is there in the denominator. You can divide numerator and the denominator by cos square x. What will come? 1 by 1 plus 4 tan square x. We are dividing numerator and the denominator by cos square x. So now what we have to do? Now we have to take tan x is y. When this type of problem comes, no, we have to take tan x is y or y is tan x. In some cases, we can take y is tan x by 2 also. So now we have to take let tan x is y secant square x is what? 1 plus tan square x this gives the value of dx is dy by 1 plus tan x is y, so it will be y square. Now dx is dy by 1 plus y square. This becomes 1 by 1 plus 4 y square. Tan x is y, y square. So we can take like this. Now we have to change the limit to when x is 0. X is 0, tan 0 is 0, so that means y is 0. When x is pi by 2, by 90 degree, tan 90 is infinite. So y is equal to infinite. Therefore, 1 becomes y is equal to integral 0 to pi by 2 becomes 0 to infinity. Then 1 by 1 plus 4 tan x is y, tan square x is y square. What is dx now? Dx is dy by 1 plus y square. So 1 plus y square dy. Now we know how to proceed because this is we have to use partial fraction. Can write this as 4y square is there, 1 plus y square is there. We can write in terms of 1 plus y square. How to write? 0 to infinity 1 by 4 times y square plus 1. This I rewriting 4y square plus 4. We want only 1. So minus 3. This is one term. Then 1 plus y square into dy. We call this as 3. Now consider only this portion we are taking 1 by 4 into y square plus 1 minus 3 y square plus 1. This, how we can write this now? A by, or we can write this as 1 by 4 z minus 3 into z, where z is y square plus 1. Y square plus 1 is z. Z 4z minus 3. 4z minus 3 into z comes. Let in this put z is 0. So this term vanishes. Z is 0. Minus 3b is 1. We'll get the value of b. Put z is 3 by 4. So this vanishes. We'll get the value for a. A is 4 by 3 and b is minus 1 by 3. Therefore, this becomes 4z minus 3 z. This becomes a is 4 by 3 by 4z minus 3 minus 1 by 3 by z. But what is z? Y square plus 1. Therefore, 1 over 4y square plus 1 into y square plus 1. So this is equal to 4 by 3 times, this is nothing but 4y square plus 1, then minus 1 by 3 times y square plus 1. On integrating, or we'll take it outside. So into 1 by 4 integral dy by, we take 4 outside, y square. Here 1 by 4, that becomes 1 by 2 whole square. Then minus 1 by 3 times integral dy by y square plus 1. One by 3 times this integral dx by x square plus a square form. So 1 by a tan inverse x by a, here y by half, minus 1 by 3 times 1 by 1 into tan inverse y Now y is infinity, tan inverse infinity is pi by 2. Then tan inverse 0 is 0. Minus 1 by 3 times tan inverse infinity is pi by 2. So pi by 3 minus pi by 6, that is equal to pi by 6. This is the answer. So in this integral we can see sin x plus cos x is there in the numerator and the denominator has a square root of sin 2x. We know how to write 1 plus sin 2x. We already seen, no, 1 plus sin 2x we can write sin x plus cos x whole square. So here sin 2x, so this is nothing but 2 sin x cos x. So we can write x sin x, here plus is there, so I am writing minus here. Sin x plus cos x is there in the numerator. So here I want to write sin x minus cos x form, so that if we differentiate sin x, cos x comes. If we differentiate minus cos x, sin x will come. Now if I expand this, what will come? Sin square x plus cos square x 1. So that is minus 1. Then minus 2 sin x cos x. So that means minus we have to put here. Okay. So sin square x plus cos square x is 1 minus 1 gets cancelled. Then minus 2 sin x cos x, that is minus sin 2x. Now sin 2x, how we can write now? So that means the sin 2x is 1 minus of sin x minus cos x whole square. Now we will take sin x minus cos x is y, 2 pi by 3, when x is pi by 6, y is how much? Sin 30 is 1 by 2, cos 30 is root 3 by 2, so 1 minus root 3 by 2. When x is pi by 3, 60 degrees, sin 60 is root 3 by 2, cos 60 is half, so it's become root 3 minus 1 by 2. So if we differentiate this, what will come? Sin x is dy. Therefore, 1 becomes, first we will write sin 2x as 1 minus of sin x minus cos x whole square, and then we will write x in terms of y. So pi by 6, pi by 3, sin x plus cos x by square root of 1 minus of sin x minus cos x whole square dx. Now we will write x in terms of y. So pi limit varies from 1 minus root 3 by 2 to root 3 minus 1 by 2, sin x plus cos x into dx. Sin x plus cos x into dx is dy by sin 2x, square root of 1 minus sin x minus cos x is y. This is y square. Therefore, I is equal to, what is integral dx by square root of a square minus x square? That is nothing but sin inverse x by a. So this will be sine inverse y by 1. So sine inverse y where is from 1 minus root 3 by 2 to root 3 minus 1 by 2. Now this will be sine inverse root 3 minus 1 by 2 minus of sine inverse 1 minus root 3 by 2. Here sine inverse of minus x is minus sine inverse x. Sine inverse of minus x is equal to minus sine inverse of x. Using this property, we'll take minus sign outside, then it become plus sine inverse root 3 minus 1 by 2 becomes. And sine inverse of minus of root 3 minus 1 by 2, that minus comes out, it will become plus. So this becomes 2 times sine inverse root 3 minus 1 by 2. So this is the answer. We know that we have to rationalize the denominator. Multiply numerator and denominator by square root of 1 plus x plus square root of x. Now the denominator is in the form a minus b into a plus b, that is a square minus b square so 1 plus x a square minus b square. So 1 plus x minus x. So this the denominator simply becomes 1. Now if we integrate this one, so we can write integral 0 to 1, 1 plus x power half plus x power half dx. Now if we integrate, what will come? 1 plus x power 3 by 2 by 3 by 2 plus x power 3 by 2 by 3 by 2. 0 to 1, 1, then minus, you put x is 0, so minus 1 minus 0. So this becomes simply 4 root 2 by 3. So this is the answer. So we can see sin x plus cos x is there in the numerator, sin 2x is there in the denominator. So we can write sin 2x in the form of sin x minus cos x whole square. 16 sin 2x 9 plus 16 sin 2x is equal to 9 plus 16 times 1 minus of sin x minus cos x whole square. For sin 2x, we written this here. So now this becomes 9 plus 16, 25, then minus 16 times sin x minus cos x whole square. And we can take 16 outside, then 25 by 16 minus of sin x minus cos x whole square. We have to take sin x minus cos x as y is equal to sin 45 degree minus cos 45 degree. 1 by root 2 minus 1 by root 2 is 0. And if we differentiate this, cos x plus sin x dx, it becomes dy. Therefore, 1 becomes x varies from 0 to pi by 4, y varies from minus 1 to 0. Sin x plus cos x dx becomes dy by 9 plus 16 sin 2x is nothing but 16 we have taken outside, 5 by 4 whole square minus so integral dx by a square minus x square form. So 1 by 2a 2 times 5 by 4 log of a plus x 5 by 4 plus y by 5 by 4 minus y. Limit is minus 1 to 0. So this becomes 4, 8, 40, 1 by 40 times. Put y is 0, log 5 by 4 plus 0 log by 5 by 4 minus 0 will become log 1. Minus, then put lower limit y is minus 1 log of 5 by 4 minus 1. So it will become 1 by 4 by this minus 1 means it will become 5 by 4 plus 1. So 9 by 4. So 1 by 40 log 1 is 0. So minus log of 1 by 9. So this becomes 1 by 40 times log of 9. So this is the answer. Minus n log m power n. This minus 1 taking here, then 9 comes to numerator.